Today. Yeah, today we're in for an adventure. Yeah, so yesterday we did 6.2, which was simplifying polynomials, right? Remember, we just had fractions of polynomials, we factored them, and then canceled any like factors. Sorry, yeah, 6.1 is what we did yesterday. This will be 6.2 that we're doing right now. And then we're going to do 6.3 in a little bit. And 6.2 is pretty, I don't want to say basic, but if you remember how to do yesterday's assignments, 6.2 shouldn't be that big of a problem. So basically, the rule that we're working off of for 6.2 is the basic rule of multiplication of fractions, right? A over B times C over D is just equal to AC over BD, right? And so we multiply straight across the top and straight across the bottom. That's all we're going to be doing when we're multiplying. So for example, right, here's an example. If I wanted to multiply 4 over 7 by 3 over 10, I get 4 times 3 over 7 times 10, which is 12 over 70. This is what it looks like with a polynomial, right? X times x minus 1. This is the thing that people forget a lot, is to put the x minus 1 in parentheses, right? And so it's the entire numerator of one fraction multiplied by the entire numerator of the other fraction. So to be safe, you could always consider everything sort of in brackets if you wanted to. And so the same thing happens on the bottom here, right? We have a 3 in the denominator, an x plus 5, and the next step has x plus 5 in parentheses times 3. It's really important to leave those in parentheses. So one thing to remember when we're multiplying things that are already factored out, if everything's fully factored already, you're already in the best position to cancel things, so you don't need to factor further. And we'll go over examples like that in a little bit. All right, so suppose I'm asked to multiply these two ugly expressions together, 7x to the 5th over 3 times 6 over 2x. So if I'm asked to multiply that, this is multiplication, so I multiply straight across the top, which gives me 7 times 6, 42. That's 42, and then x to the 5th just stays there. Then I multiply straight across the bottom. 3 times 2 is 6, and the x doesn't really do anything. And so now the last thing to do in all of these problems is to simplify anything that we can. So let's see now, 42 over 6. I don't know if that goes in there evenly. I don't think it does. Oh, of course it does, because I just multiplied to get that. Okay, so so you guys are probably laughing at me at home. All right, so I have 7. All right, 42 over 6 is equal to 7. And then I cancel one of my x's on the bottom. And that leaves me with x to the 4th. And so even though this was kind of like more, you know, this is an example with two monomials, it works the exact same with, you know, trinomials and binomials. We might just have to factor things before we cancel. With monomials, it's already all multiplied together, so you can just cancel. So let's try our first one of these. So in the first one, we have x squared minus 3x minus 10, and that's multiplied by the fraction x plus 4 over x squared minus 10x plus 25. So something that we just need to remember here, since this first one doesn't appear as a fraction, right, we can consider this over 1. And so when we're multiplying, I multiply straight across the top, which is this big ugly trinomial, x squared minus 3x minus 10, in parentheses, times x plus 4. On the bottom, I have...
You and I forgot it was hell.
Dude!
What's going on?
I didn't think you were going to show today. I thought we were... What are you dressed as? Are you a cop?
Yeah, she's a cop.
The irony in that costume.
Yeah, it is actually pretty fun. No, that's why I did it.
That is awesome. I like it. Okay, so remember, on the denominator, we just had 1 times this polynomial. Right? So in our denominator over here, we just write that polynomial. Whoops. Minus 10x plus 25. Yeah, the costumes start to blend in after a while, and you do forget that you have yours on.
Yeah.
And like a student came in this morning to talk to me, and she kept looking at me like I was some sort of clown, and I was like, "Oh, I have this stuff on. I'm a wolf, I guess."
Oh, okay.
Yeah.
I feel like they almost belong with you, though.
Hey, like I'm glad I haven't cut my hair and I went for the homeless look recently, because like this really like blends in, you know, like it's fine.
I thought you just had a weird bun. What's going on here?
It's my man bun.
Yeah, I waved to the cop that was out there. I was coming out of my car. I was like, I don't think they looked. But...
You should have been like, slow down.
I'm wearing a costume.
Keep it down.
Yeah. No, he's just stopped there trying to catch speeders.
Oh gosh. Okay, so let's jump back into the problem. So what we were doing is we're just multiplying rational expressions together. So basically we're multiplying fractions made of polynomials.
Okay, I might have a lot of questions.
That's okay. That's okay. So now, basically what we do now is factor what we can factor and then see if we can cancel. You might be really tempted to multiply these two things together. Don't ever do that. It's going to come out super ugly if you do that, right? If it's already factored, just leave it factored and then factor some more, right? You won't get different factors if you put it all back together. So let's see if I can erase this. There we go. So now basically what I want to do is on my next line, I'm going to factor this polynomial out and this polynomial out and see if I can cancel anything. So at least with this polynomial that I'm highlighting in blue, it's just a basic shell because I don't have a coefficient. And I'm looking for two factors of 10, right? There's a negative here, so this is plus and minus. So I'm looking for two factors of 10 that differ by 3. Well, that's just 5 and 2. Since the 3 has to be negative, the 5 goes on the negative, and the 2 goes on the positive. And then this other factor that was up top, this x plus 4, this just stays there, right alongside. Now we just need to factor the one on the bottom. And if you notice, if you look at this thing close enough, you'll realize I'm pretty sure this is a perfect square. And so this, oops, I'm not going to write it out as a perfect square though, because it's more convenient to cancel. So for this one, we have our basic shells again, right? And we say, okay, for our factors here, we have a positive 25, which means these two numbers both must be positive or both must be negative. The middle's negative, so they're both negative. So that means we're looking for two factors of 25 that add to 10, right? That's pretty obvious.
What could they be?
I don't know, right? And so, you know, and so now we've got everything factored out and we cancel any like factors. There are only two, which is always a little disappointing, but that's okay. So we cancel whatever we can, and then we have x plus 2, x plus 4 remaining over x minus 5. And there we go. Okay, so basically this is the same thing that we learned in 6.1. We're just like multiplying things together first.
If you watch the video for 6.1.
Yes.
Yeah, I'm gonna have to rewind. I mean, I sat down through class, but I went to do the homework and was like, yeah, okay.
Basically what we learned in 6.1 was simplifying, like we learned how to simplify this thing alone, right? And basically what we learned was that we just factor the top and the bottom and then cancel anything that's like. That's it. That was the whole lesson.
Watch it. I just had a crying dog for 2 days.
That's okay.
Yeah, he went to the dentist. He didn't even get a tooth pulled. Well, the dog dentist, yeah, he got his teeth cleaned.
Oh, that's
and he was so high for 2 days.
2 whole days?
Yeah. They're like, oh, he hit the drugs a little hard, and then he's crying at me for 2 days straight. Just sits there. And now he's fine. I don't know. He was high as shit.
They over the poor thing.
Yeah, he was
Probably
20
did,
pounds,
huh? Oh gosh, they're like, oh, did we give him the 60-pound shot?
Yeah.
I'm sorry.
You're like, yeah, he hit it a little hard. Oh my god. What did you do to clean his thing? Yeah, I was just like so annoyed. He was just being a little baby and I was baby.
I love you.
Yeah. I was just rubbing his back for 2 days. I'm sorry. I got high once.
All right, so for this one here, once again, multiply straight across the top, straight across the bottom, because it's just a fraction in the end. So this step that I'm doing right here, this is one that eventually you might just take out of your homework because it might be unnecessary.
What do you say?
Yeah, that's true. That's all I say.
For us slower, older people, we're still functioning under cheese whiz logic.
I think I might be older than you. I don't know.
Okay, so
This is, and I only say that this step might be a little bit unnecessary because the only thing that we've done between this step and the last is just get rid of the multiplication sign and sort of extend this fraction here, right? It's kind of like, it's sort of like a step that says, yeah, we're multiplying these things together, but we really didn't do much in that step. Right, and so now we one at a time factor out all of these, right? And so I say, okay, first I'm going to factor that and then move on. So to factor that, it looks like I could pull a 10 out and that's about it, right? So I have my 10 on the outside and then I have an x plus 2 on the inside. Now I'm going to factor this one here, x squared minus 1. You guys remember what that factors into? This is one of those super common ones. It's okay if you don't remember yet.
X minus 1 squared?
X, not quite. So this is, you're on the right track though. So this one here is a really, not famous, a really common difference of squares, right? X squared minus 1 squared. So this breaks up into x plus 1, x minus 1.
Oh.
Yeah. And don't worry about it if you haven't memorized that yet. I'm bringing it up to help you guys memorize it as you go. Okay. Now I'm going to take a look at this lower factor here. And that one, I'm tempted to do a factor by grouping, but the coefficients are both prime, right? Like 2 is a prime number, 1 is a prime number, so guessing and checking this thing is actually going to be pretty easy. And since the first coefficient is 2, there's no other way to break this up other than 2x times x for the first terms. Right? That has to happen. Snapdragons, I like that.
Okay.
So when we look at this one and we say, well, I don't know, what should I guess first? We can see that our last term is a positive 1. And so both of these here and here, this can only be 1. The middle term is a negative, right? And so these two have to add to negative numbers. So negative 1 and negative 1 are the only two options. Danny, are you thinking, that wasn't so easy to guess and check? And that's, you'll get used to that. I know it feels very sketchy at first, But if you can make your shell, if your first number is prime, then you can always make your shell out to begin with, and then you can at least sort of see what kind of multiples need to go in here.
I just keep remembering that I still have a bunch of side work to do, and I haven't been able to do the side work because I've just been trying to do the homework.
Gotcha. Yeah, and this problem, the one that I've got highlighted in green, like, you know, we might do some side work on that one, but like I said, like the guess and check is pretty basic, sort of basic. I'm supposed to say that with an attitude. It's basic. Yeah. So now.
5 times x plus 2.
Have you been waiting for that one?
Yeah.
You've been locked and loaded, huh? All right.
It's 2.
Did you guys think we could factor a 3 out?
Yeah.
No, that's not it. All right, so I factored the 5 out, and I have x plus 2 left. Okay, now that I've factored every single one of those completely, I look for any matching factors down here.
You
So
can divide the 10 by the, or the 5 by the 10.
Oh, nice. Yeah, you can absolutely do that. Yeah.
I'm sure you were gonna.
Right? They're all like,
If you could.
they're like kind of buried in here, aren't they? Right? Yeah, I have a 10 and a 5 there, so those simplify to 2. Let's see now. My x plus 2's cancel.
Now we're at the point where we're canceling stuff.
Yes. My x minus 1's cancel. I dealt with my 10 and my 5. So all I have left is my x plus 1 on top and my 2x minus 1 on the bottom.
But we can go further.
No, we cannot. Yeah,
Well,
right? Yeah, you
like,
might have been
like, we're
tempted
gonna
to
do
cancel these, but
No,
you can't do
I was
that.
tempted to do 2x plus 2.
2x plus 2. Oh, okay. You were thinking distribute back
Yeah,
in
yeah.
and then cancel some stuff out. Yeah, and interestingly enough, that like it never works.
Okay.
Because and that's something that I always tried to do when I was learning this, but after a while you figure out it never works because you fully factored in up here. If nothing cancels after it's fully factored, nothing's going to cancel by multiplying stuff back in.
Okay.
You know, it's kind of like it's this weird thing, yeah. And at first you want to think it works, but eventually it doesn't. You could try it a few times and waste some time.
Well, I mean, what if you take the 2x out after you put the fact that.
Oh, careful though, because you're thinking 2x plus 2 over 2x minus 1, right? We're not allowed to cancel these 2x's because they're not multiplied, they're added or subtracted.
Because, I mean, they're technically multiplying each other, so that's why it was.
Yeah, that's true. But like you can't, it's kind of like you can't cancel over this. It's sort of like if you can't factor something out first and then cancel it, you can't cancel it. Yeah. Although like everybody wants to do that, including me, because it would be really nice if I could just cancel that.
I don't feel like a desire in my heart to do it, but I also would like to know.
A desire in my heart.
Yeah.
Like, I don't have a massive desire to do this. However.
You're like, actually, I don't have a massive desire to do anything in this class.
My dog wouldn't let me do my homework.
Is that your dog?
No.
What kind of a dog is it?
Is your dog texting you? Just like whining a little bit.
No, but I literally got this far on 5.3 before he was just like 24. If I paid attention to anything but him, like I knew he was being a rat, and I was being a bad parent for that.
Grab a hold of the little thing that I put my laptop on, and I'll put my math and stuff on it on my laptop, and I'll put it pause in the little laptop part and try and flip it.
Well, I was scared he was in pain a little bit. I didn't know if they like cleaned his teeth really hard or something. Good one thing. I just kept rubbing his back because that was the only thing to make him stop. So I just stopped doing my homework. And I could do my 2 online classes. I'll catch up later.
So we'll see with this next thing that we're doing. This is, if you remember the rules for dividing fractions, this is the exact same thing. The rule basically states that the divisor, which in this case I'm highlighting in yellow here, C over D, all we need to do to divide these two fractions is flip the divisor over and change division to multiplication. And that's it.
Okay.
Yeah, this section is not super complicated as to the operations we're doing.
Wait.
Oh, sorry.
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 Okay. Continue. I just want to make sure I have that right.
Okay, so for this first example, they want us to divide x over 5 by 7 over y. So on my very first step, I leave x over 5 the same. Instead of division, I write a multiplication symbol, and then I flip the second fraction. 7 over y becomes y over 7.
Okay.
Then I just do my normal multiplication, right? Straight across the top gives me xy. Straight across the bottom gives me 35. And that's it.
If
Then
only
we factor.
all math was
Well, yeah, well, you know this is about to take a step up, though, right? Like, we're going to do this with trinomials in a second. And then, yeah, you're absolutely right, though, that if we're working with trinomials at this part, then we factor everything out, see if we can cancel.
I was just trying to see if you thought I was that dumb. X divided by 35 is...
No, I think you guys are all super smart.
I think you guys are all equally dumb.
I feel like at this point, we should all just be allowed to choose to express math in our own personal way, as long as it's math related, and get a passing grade.
No,
Ever.
no, you're thinking of art class.
Yeah.
All right.
All right.
So for this one, right?
We're putting the phantom 1 in there to make it equal, right?
Exactly. Yeah, we're putting the 1 in there just to make this kind of make sense. So the first fraction stays as it is, x plus 2 over 1. We change the division to a multiplication symbol, and then we flip the second fraction, x plus 3 over x minus 1. And the great thing about this problem is that everything's just factored already, right? When we multiply everything in and we put our parentheses there, we can see that none of this stuff can be factored any further. Nothing cancels either, though, so that's kind of a bummer. It sort of does. I mean, I guess we still technically divided the polynomials, but
We just moved some of the things.
right, we sort of just rewrote some stuff. Yeah. I always feel better when I can cancel.
If this was in the homework, I would not show my work.
Gotta show your work.
Yes.
All right, here's one that probably will cancel. It better, because it looks ugly. So first step on this one.
You made it.
First step on this one, we leave the fraction the same, right? And so we have x squared minus 2x minus 3 over x squared minus 4. We change the division to multiplication and flip the other fraction. Does that voice bother you when you're behind? And I'm like, and then we flip the fractions. You're like, slow down.
Little, like, Doom Patrol yet?
No.
Oh, man.
It's ironic. She's a stable genius.
Yeah.
She's very sane.
Stable
Yeah.
genius, yeah.
It's like a librarian.
No, that's crazy, Jane, right? Yeah. Everybody's like, what? All right, so now that we have flipped and turned it to multiplication, we take this next step that might not be necessary in your homework, but I like to do it for now. So I have x squared minus 2x minus 3 times x plus 5 over x squared minus 4 times x plus 1. So now, one at a time, we take a look at all these and try and factor them.
X plus 1 times x minus 3.
Boom. Nailed it.
You rock.
Nicely done.
Don't think I didn't sit here with a headache for like 2 seconds.
For like 2 seconds.
Yeah. It was a hard 2 seconds.
And notice how this other factor out here didn't mess with it, just left it there. Don't mess with that other factor. It only brings trouble. Okay. So now, this one looks very similar to something we broke down earlier.
Oh.
All right, this looks a lot like x minus 1, except for it's slightly different. All right, what should this factor into?
X minus 2, x plus 2.
Yes, there we go. X minus 2, x plus 2. And then the x plus 1 is still there. All right, so now any factors that match, we cancel. Boom, boom. And that's it. That's pretty lame. I like it when everything cancels, honestly, but can't always get what we want. All right.
I mean, you could change this.
I know, but I want to set you guys up for the for the disappointing. Yeah.
I want you to get excited about your math.
If everything cancels in the lecture, when you get to the homework, you're just going to be super angry at me. You'll be like, what? Nothing cancels. Yeah. Yeah, that really does happen. It's tragic. And then you start like second guessing yourself because you're like, wait, if I did this right, something should cancel, right?
Yeah.
It's not always the case.
So there's gonna be one though.
Yeah. Yeah, there'll be quite a few actually that you'll every once in a while. I tried to eliminate the ones in the homework that went like that, but sometimes there are ones in the homework where you're just like factor, just full page of factoring, and then nothing happens.
Yeah, I was waiting for that in the homework of the first 5.4, and none of them are even prime.
Yeah, I don't think
I was kind of excited to be like, yeah, this one doesn't work.
I try to avoid primes.
Yeah. I kept expecting it to happen. I was like,
right.
The viewer, I was like, oh, it's prime after I did all this work. But they weren't. I was just wrong.
There was a prime in the homework, like before I even introduced the concept of the prime polynomial, though. So it was kind of like it came out of order.
And on 5.4, and on 5.3.
It was one of the first ones. It was like 5.1, I think. We did factoring by grouping, and that was what made it so terrible. Was that it was a factoring by grouping, but it was prime, so you couldn't really tell. Yeah.
Where I was like, yeah. I remember that now, yeah.
All right. So
that's why I'm so prepared this time.
So in the case when your second fraction is not really a fraction, it's just sort of like a polynomial, you do the whole thing where you put it over 1 again. Okay. So then on my next step, I write z squared minus, oh, this is going to be trouble, 2z. Hopefully we can tell the difference between my 2's and my z's here. Plus 1 over z squared minus 1. Ooh, I know how to factor that out. And then I change my division to a multiplication, and then I flip that other fraction. Guy dressed as Batman served me biscuits and gravy this morning.
That's awesome.
Yeah. I was like, thank you, Bruce Wayne. It's down at A&P.
I love how. Oh, they're wearing their costumes.
Yeah, in the deli department, they got good ones on. All right. So now, instead of doing that step where I write the whole thing over again, I'm just going to sort of rewrite this step. Extend that, put parentheses around these, and here I am. Right, and so if you don't necessarily want to take all those steps every time, which I don't usually want to, it's okay to write the next step in as this. Okay, so now we factor all these things out. So the first thing I'll factor is this upper one, z squared minus 2z plus 1. That factors into, let's see now.
Z minus 1 squared.
Yep, 2z minus 1s. Good.
I feel like you're in a game show.
And the answer is Bob.
I play game show host when like elementary school kids come up. We have this Jeopardy game that we play with them. And it's Who Wants to Be a Millionaire? And I always tell them they're going to win $1 million in the end. But the answer to the last question is, what's the difference between the lifetime salary of a college degree holder and a non-college degree holder? And it's $1 million. And the kids are like, where's my $1 million? And I'm like, there you go. Go get a college degree. And you get $1 million. You're welcome. And they're like, you're a jerk.
You have more of those kids left. You're like, whatever. I'll do the same thing
Right.
for trade school.
They're like,
We
college
need
is a
more
scam.
people of that. Apparently, I read it on Facebook.
For trade schools?
Yeah. I don't know if people are going. I didn't read the article, I just read the headline. See?
So this one highlighted in green, right? We know what this one is. We did it earlier. Z plus 1, Z minus 1. Then we have this guy down here in yellow. Kind of a bummer that
It's prime.
it's not prime. I doubt it's prime. But it's just, we can see the coefficient up here is not prime. So that means there might be more to guess and check than I really want to go through. So I'm going to do a grouping method so that I don't have to guess and check. So I'm just going to scooch over here to the side. Scooch. I love that word.
4 times negative 3. Right?
Yeah,
You
exactly.
on that table? Okay.
Okay, yeah, so we're going to do the table. And so just like you said, over here we do A times C, which in this case is 4 times negative 3, which gives me negative 12. So the middle coefficient is negative 1. Right over here are my sums, and I want negative 1.
I thought, oh, just kidding. I thought your Z was in 3.
Darn it. I gotta do it like this or something. There we go. All right, so sure, I could try 6 and 2, but I know that's not it. I know that 2 factors of 12 that differ by 1 are 4 and 3. And if I want negative 1 in the end, I have to put the negative on the 4. Okay, so I already know that 3 minus 4 gives me negative 1. So those are the factors to use. So now my first term drops straight down. I have 4z squared. My middle term breaks into the factors that I found. So I have negative 4z plus 3z, and then minus 3. And so now I do factor by grouping on these 4 terms. In the first 2 terms, I can pull out a 4z. That's going to leave me with z minus 1. And then in the second 2 terms, it looks like I can pull out a 3. So that leaves me with z minus 1 again. Make sure that these 2 factors match, and then I can write them out front. Z minus 1 times 4z plus 3. Plus 3. These are z's.
Oh. I just saw what's going on here.
Okay, so now all the way back, and we write what we had factored in where that old polynomial was. So z minus 1 times 4z plus 3. Okay. Hey, good. Looks like multiple things cancel here. All right, we have a set of z minus 1s. Whoops, sorry, we have two sets of z minus 1. So all those cancel, and we're just left with 1 over z plus 1 times 4z plus 3. And remember, just remember that when we cancel everything out of the numerator or the denominator of a fraction, there's still a little 1 that stays there. Okay, so now we are going to move on to 6.3, I think. Let me make sure there's nothing. Yeah, there's nothing left here. So 6.3. 6.3, we start learning about addition and subtraction of these big rational things that we're working on. This is definitely a little more complicated than multiplication and division. So just to warm up here, let's go over some prime factorizations. Right? Remember, every number can be factored into prime factorizations. So remember, right, 36 is just equal to 6 times 6, which is equal to 2 times 3 times 2 times 3. So the prime factorization of 36 is just 2 times 2 times 3 times 3, right? Yeah. You know, if we wanted to find the prime factorization for 40, remember we can use the little factor tree method where we just draw our branches out for each factor. So I have 4 times 10 equals 40. 4 splits up into 2 and 2. 10 splits up into 2 and 5. Since I reach all prime numbers, this is my prime factorization for 40. Okay, so just recall that we do that with numbers. That's something we do. So now let's go over the first type of addition we're going to talk about today, and that is the easy type of addition. The easy type of addition of fractions basically is just when our denominators already match. Right? And so you can see here, when we have two denominators of b, we just add the numerators, and the denominator stays the exact same. Nothing happens to it.
That addition or division? Oh, that's addition.
Sorry, yeah, this is addition. That one's a blurry picture.
There.
But the smiley face makes up for it.
It's, yeah, here.
I know.
Yeah. Okay. What was B?
What do you mean? What?
All right, I just realized that it says for each of the following numbers, and I only had 36. So
That's okay. It was 40, but that's okay. That's okay. That was only to warm up, though. That was just kind of like to warm up with the factoring. This is kind of the more important stuff.
I'm going to look at my notes and I'm going to do
Okay. God. So if we're asked to add, right, these are the easy cases, right? If I say, oh, look at that, how convenient. I have two A's on the bottom. Well, the only thing I do is I write my new fraction with a single A on the bottom, and then I add the numerator. 4 plus 3 plus A. That gives me 7 plus A on top, and plain old A on the bottom. Once again, an easy case. And so I noticed my denominators already match. Was it? Did I just hear?
Sorry. No, you're fine. I'm just
looked up from your page.
So I keep the same denominator, right? And then I add the numerators together. And so I can just see, if I add these together, I have 3x squares. I have 3 plus 1, plain old x's. And then I have -7 and -8 for my constant terms. So that's minus 15.
That feels so wrong.
Yeah, so this is kind of a strange problem, actually. And here's the reason why. So this is a problem that if you recognize the logic behind why we don't need to go any further in this problem, it might save you some time later. So think about the way that this top thing is going to factor. My bottom is going to stay as 2x plus 1, and the top, the only way to make the top into factors, this is a prime number, so it would be 3x and x. Is anything going to cancel? No, it won't. And the reason is because nothing up here starts with 2x, right? What's on the bottom does. And so if we were to cancel, it would have to be a 2x plus 1. Since this doesn't factor into anything like a 2x plus 1, we can actually stop right here and call it good.
Oh, wait. On this easy case, this is it.
That's it. Yeah, on the easy case, you add the numerator, you try and simplify. If you can't, you can't. You're done. On a lot of examples, you can actually simplify, though, so watch out for that. But there are yeah, but there are plenty like this too, where it's kind of like, oh, like I could take the time and factor this ugly thing by grouping, but I also noticed that even if I do that, these factors will never cancel. So I'm wasting my time in doing that. If this one on the top started with a 2x or like a 4x or something like that, then you'd want to factor and check. But the 3x means that we won't be able to ever cancel with a 2x. So we just move on. Okay, and I also noticed that my time is running a little bit short, so I'm going to start moving on because those are the easy examples.
Okay, cool.
All right.
After I start copying.
Okay, subtraction when denominators are the same. This looks almost the exact same except for it's subtraction. There's even a smiley face on this. So, and I'm gonna actually skip through most of this too because the really weird stuff is coming up, and I want to give a little bit more lecture time on that. Just the particulars to remember about subtraction. It works the exact same as addition. The thing that will trip you up, though, that's different, is that whatever's back here in the second denominator, you have to make sure you put that in parentheses outside, or with the negative outside. Right, and so this negative sign has to apply to both the x and the -5, right? And so just when you're writing out your subtractions, the numerator that's being subtracted gets wrapped in parentheses. And we'll come back to some more of those examples if we have time. But that's really the only difference between subtraction and addition, is just making sure that you do this. That's it. Besides that, it's the same.
Wait, you can't like factor that?
I could. I'm not going to keep going with this problem though. Yeah, yeah.
I was wondering if I was wrong.
And let's see now, 3x minus x. Yeah.
2x minus 2x plus 5.
Right.
That's it.
Yeah.
Nothing underneath.
Yeah, and so yeah, no, yeah. So you'd keep going with that problem, but yeah, I'm just showing you kind of like the particular for the subtraction.
Okay.
So now that
right,
yeah, absolutely, cool. Yeah. So now that we've gone over that, let's talk about least common multiples and denominators. Okay. So recall how we add fractions currently. Right, if I want to add or subtract two fractions, their denominators must match. If they don't match, we first convert those denominators to something common. And the way that we do this with regular fractions, it's the same exact way that we're going to do it with polynomials, right? It's just with things that are a little more complicated and ugly looking. So the first thing we do is we say, suppose we wanted to add 1/6 and 3/8. The first thing we do is list both denominators, 6 and 8. list their prime factorizations, 2 times 3, and 2 times 2 times 2. We choose one of them. I'll just choose 8. 2 times 2 times 2. And then we multiply it by any factors that it's missing from the other. And so I have 3 2s, so the 2s are all covered. I just need to multiply this by 3 to get the number I'm looking for. And that gives me 24. Another way to look at the common denominator sort of operation, I had somebody tell me that this was an easier way to view it. Let's see now. I'll just do it kind of over here. So if you had 6 and 8, you do the same thing when you start out. 2 times 3, 2 times 2 times 2. And somebody told me this is an easier way to look at it. They said, if a factor exists in one of these two, your LCD contains the largest number of those factors, right? And so I say, oh, 2 is in both of these. This one's got 3 of them, so this must have 3 of them. Whoops. It should be a 2. 2 times 2 times 2. And then I say, okay, a 3 exists in one of these. It's only 1, so that's got to be multiplied in as well. I don't know if that helps at all. We'll do that a bunch more times. Probably doesn't help.
Yeah, those.
I got that look on your faces like that doesn't look right. Okay, so now remember, now that we found the common denominator of 24, we need to convert both of these denominators into 24 before we add these fractions. So 1 over 6, that gets multiplied top and bottom by 4. Right? The factor it's missing from 24. Then the 3/8, that gets multiplied top and bottom by 3. Then we have 4 over 24 plus 9 over 24. And now that we have matching denominators, we can just add these, and this gives us 13 over 24. Okay, so that's the same exact bit of operations we're going to do on polynomials. It's just more of a pain to factor a polynomial. So suppose I was asked to find the... Oh, sorry. Okay. So if I'm asked to find the LCD of these two fractions, right? And so suppose somebody's saying like, hey, add these things together. I list the denominators on the side. So I have 36x squared and then 24x. Write out prime factorizations. So we did the prime factorization for 36 earlier. It was 2 times 2 times 3 times 3. Then I have an x squared. 24, that breaks down into 6 times 4. And so that's equal to 2 times 3 times 2 times 2. So that gives me 2 times 2 times 2 times 3 times x. Okay, so there are my prime factorizations. I want to select one. I'm just going to select the larger one. That usually makes things a lot easier. I write it out. 2 times 2 times 3 times 3 times x squared. And then I say, is this missing any factors from the lower one? Well, the lower one has 2 factors of 2, and so does the thing we just wrote out, but it doesn't have 3 factors of 2. So we need to multiply one more factor of 2 in here. And then the number we chose to write out, that had 2 copies of 3. This lower one only has 1 copy, so we're good on the 3s. We have enough of those. The same is true of the x's, right? This lower copy, or the lower number only has 1x. We already have 2 in there, so that's completely covered. So really the only thing we were missing was a 2 in the end. And this gives us 72x squared. Let's see now, is that it? Oh, that was the last bit of that problem. So there we go. So that's how you do it with a monomial, right? You find the LCD like that. You might want to keep the process open in your book when you do the homework. The LCDs are a little bit weird to find at first. All right, so moving on. Let's keep finding these LCMs here. Okay, there we go. Because you got to know how to do this to add these fractions, right? If I give you 2 fractions with these as denominators and tell you to add them, this is what you're going to have to do. Yeah, this is kind of painful.
Yeah,
no,
I don't mean to have any attitude at all. Like this, like
It just sucks, you know?
no, I understand that, and you know what? I also apologize if I ever seem like I have attitude up here.
for everybody at home listening, we all apologize for having attitude. Yeah.
You guys at home, I expect apologies from all of you
We're not showing up our house.
for your attitudes. All right, so this one is 15a, 35a. All right, 15a splits up into 5 times 3 times a. 35a splits up into 5 times 7 times a. I'm going to select one of these. Oh, yeah, please shut that.
I wasn't even that far yet.
We don't usually worry about it next gen because the sun's not going to come out anyway, but today we did.
I could have really easily done that, and I just watched you suffer.
Hello,
Really
public
bad.
service.
Like a real cop.
Sorry,
cops.
Thou shalt just sit here and watch.
Is that no?
No.
We gotta shut that line. So you guys at home, just remain patient.
Sorry, guys. I feel like any other teacher would have paused just the
No,
recording.
that makes the video boring.
Yeah.
Like it's
Everybody at home is going to
it's
be
funny.
laughing.
Yeah, it's funny to listen
No,
to chaos.
on YouTube you can just like click, and then it's fast forwards 10 seconds. So everybody watching at home, I hope you did that.
They didn't. You know they didn't.
Yeah.
All right. So we chose one. We write it out, 5 times 7 times a, and then we say, what is it missing from the other? Only thing it's missing is a 3. So we multiply that in, times 3. So that'll give us,
B.
I think, what, oh, is it B? Oh, dude, thank you. Thank you for that. I totally missed that. Oh, B. I'm like, wait, is there a B in the room? All right.
It's all like almost winter. Is it B?
Okay. So right, somebody who's paying attention just noticed that we forgot the factor of B that was not in there. So we multiply B in. And this gives us, I believe, 105 AB. Okay. Sometimes we have to do this when we have a bunch of variables involved. When that is the case, right, your LCD just has to contain the maximum number of variables. And so I'll show you what that looks like. So,
Can't we divide?
oops. Divide.
What's that called again?
Divide.
Yeah, no, like, it's like
What?
21.
Oh, like, could I divide these two
divided by
things?
3.
Well, like, could I divide these two things? Yeah. Oh, you mean like when you create the LCD?
Like when we're really getting down.
Yeah. So that's a good point. So we always go up because
We don't know what the top thing on the fraction is.
Yeah, exactly. It's like if we divided both top and bottom by a fraction, we might not end up with an integer in the end.
So I guess we just multiply 7 by 3.
Yeah, we just multiply up instead of divide down. It's just kind of a weird
But, like,
thing that
call
we
it
do.
good. That's what I'm asking.
Can we what?
Sorry, I hate this.
Can we call it good? Can we skip this right now? That's what I want to know.
I hate them so much.
Okay. No, we can't skip it.
Sorry.
7 times 3, right? X cubed, y to the 6th. And then this one is obviously just the 7 times x to the 5th, y squared. Now, this is actually a good example because it shows you how to deal with a bunch of different exponents or different variables. So with this, I choose one of these. I'll choose the 21 because it contains the 7 already. So 7 times 3 times x cubed times y to the 6th. And so basically, all we need to do here is make up any number of x's, right, that we don't have. So right here we have 3. This factor this one down here that we didn't choose has 5, right? So we need to bring this one up to 5. Multiply by x squared. The y to the 6th, though, that's already got 6 copies. This is only 2, so we don't have to bring that up at all. We already have 6, and 6 completely contains 2. So this is equal to 21 x to the 5th, y to the 6th. And we got another one for you too. This is the
Wait, I chose to come to class.
right. Never doing this again.
Yeah.
Oh, I got homework for you. Speaking of that, yeah, I know, right?
Just me?
Well, I already gave Danny hers back.
It was about really serious. It's just me, thank you.
I laughed when I saw your homework that was all in red pen too. I hope you'll
Kevin
appreciate
was like trying to, or almost stole my pen, and I was like, dude, it goes full circle. I stole this pen from one of the classroom.
I hope you'll appreciate the color I graded
Yeah.
in.
There we go, yeah. Oh, that was so fast.
Yeah, I'm turning them around quick now.
Wow.
Yeah, so be careful because things might be late.
Yeah, I still have like 5.7, but or
Uh-oh.
4.7 and 8 just like missing.
Okay, that's okay.
I'll find them.
That's all right. Okay. So let's jump back into this. We got 15 minutes left. Got to charge ahead with this. So.
Oh, it's right here.
So for these two, suppose you're asked to add two fractions together that look like this. What if they say add these two together? Right? We would have to find an LCD first. I do that by writing them both down, just like I did with the other monomials. So x squared plus 5x. Just because I was because if we put the one on the bottom, then neither of these would be denominators, and we wouldn't have to make a match. You know, if I put the one on top, that means that we're adding two fractions together, and the denominators have to match. Okay, so the same thing that I did with the monomials I do here. I just write out the fraction, the factors, right? And so this first one factors into x plus 6 and x minus 1. And then x squared minus 1, we know what that factors into. It's x plus 1 and x minus 1. So I select one of these, that one there. I write it out, x plus 6, x minus 1. And I say, is this missing any factors that the other one contains? Well, they both have an x minus 1, and so I've got that one covered. But this one has an x plus 1, and the other one doesn't. So my LCD has to contain that. So this would be my LCD if I was to add two fractions with those as denominators. This ugly guy here. Let me just zoom ahead and see if we actually get into. Oh, nice. Okay, good. Sorry. I was unsure if we actually got to start adding these things together today. We don't. We just find LCDs for the rest of the class.
I'm gonna love the home.
Yeah, you probably will.
I'm gonna beg my dog to be crying.
Okay, so we've got three numbers, right? The LCD process is the same. We just list them all, and we have to analyze all three numbers for any factors that may be missing instead of 2. So I have 12x, which is just equal to 3 times 2 times 2 times x. I have 16y, and that's just equal to 2 times 2 times 2 times 2 times y. And then I have 8x, y, z, which is 2 times 2 times 2 times x, y, z. All right, so I select one of them. Doesn't really matter which one. I'll just choose this one in the middle. I write it out. So this contains 4 2's. Whoops. 2 times 2 times 2 times 2. And so now we just analyze the other factors. Oh, wait, and a y. We analyze the other factors for anything that we're missing right now. So I'll start with the 12x. I'm definitely missing a 3. So I need to multiply this whole thing by, I'll do it in a different color, by 3. And I'm also definitely missing an x. Now I take a look at the lowest factor. So the lowest factor has 3 2's. We've got that covered already. We already have 4 2's in there. It's got an x. It's got a y. We're missing the z, right?
So we're just gonna leave that there.
Yeah, no, right? There's an x and a y right here, but there's no z, so it's got to be over there. So we have to multiply the z in as well. That was kind of weird, I know. And basically, like if you take a look at this, like kind of the other sort of the other like method that I was using for this, like basically if you look at this, that method works. And so if you say, well, these contain factors of 2, so what's the most that it has? Well, it has 4. So that's what this has to contain. And if you say, well, there's a factor of 3 in one of these, so you say, well, we have to write the most factors of 3 that one of these has in was just 1, so we have that here. Right? It's kind of like you just say, what's the most factors that one of these contains, and that's how many have to be over here. If one of these down here, like suppose I had 9x, right? And this was 3 times 3 times x. I would have to multiply one more 3 into my LCD, because then I'd have one of these terms with more factors. And this will all, it's a little, I don't like the way that they kind of detach this so much. It's a little bit detached. And once you start adding the fractions together, this step starts taking place almost like in your head after a while. It takes a while. All right, let's try one more here.
We're not gonna finish it. I think that's it.
That's it.
There is, there's one more problem after this.
Okay. That's an example though.
Yeah, that's true. Examples are problems. I don't know. Okay. Oh, this is a great example here. So so when we look at these, first of all, because you guys are excellent students and you listen to me very closely, you know that this first one is not factorable because it's x squared plus a constant term. And x squared plus a constant term is never factorable, right? X plus 1, we can't really factor that, can we? 5, that's prime. Yeah. Thank you. Yeah. So our LCD is just all these things multiplied together. X squared plus 4 times x plus 1 times 5. right? So if everything's prime, you just multiply it all together, and that's your LCD. Okay, so now let's go into, let's introduce kind of the first bit of adding these things together. So right now, these guys are asking us to find equivalent expressions that have an LCD, right? And so if we were going to add these two fractions together, this is how we would start it out. And maybe I'll just add them both if I have time. So suppose I was going to add x plus 3 over x squared plus 5x minus 6 and x plus 7 over x squared minus 1. So the way that I do my LCDs when I'm actually in a fraction is I just factor everything out first, right? And I don't actually even list these things on the side because it's really easy to do without doing that. So I have x plus 3 over, and if I factor this out, right, we had that earlier, that is x and x. That is, let's see now, x plus 6, x minus 1. That's added to x plus 7 over x plus 1, x minus 1. I'm sorry I changed, sorry I went up to a different line on that. I hate it when I do that. So now, basically, like instead of doing that big long thing where we list all the LCDs on the side, basically all I need to do at this point is say, well, what factors of this denominator is this denominator missing? Right, so this one has x plus 6 and x minus 1. This one has x plus 1 and x minus 1. So that means this first fraction is missing an x plus 1. So x plus 1 and x plus 1. We multiply top and bottom by that x plus 1 that it's missing. And we basically do the same thing for the other fraction, right? I take a look at my second fraction and I say this in the denominator has x plus 1 and it has x minus 1, but it's missing an x plus 6 for my other denominator. So I need to multiply that in top and bottom. Okay, so now on my next step, since I now have matching denominators here, it's okay to add these two fractions together. And so I would write a big fraction out, right? And my denominator stays the same, x plus 6, x minus 1, x plus 1. But my numerators are the things that get added together up top. And so now I have x plus 3 times x plus 1. The plus sign is in the middle. X plus 7 times x plus 6. Since I only have 5 minutes left, and I'm not sure if they have a class in here today or not, I won't finish this one out. But this is like, remember how we were simplifying things before? To finish this problem out, you would FOIL this, you would FOIL this, you refactor, and then cancel any like terms. That's not what you'll be doing in the homework for this chapter. That's just what we'll be doing next chapter. The homework for this chapter will be mostly finding LCMs and LCDs and all that fun stuff.
Okay.
All right. Any questions? I like your, okay.
Yeah.
Right, go.
I feel bad for like anyone in the next class, like your next semester that has to watch what I made. Like, why are all these long pauses?
It's okay. It's okay. It's
Somebody's screaming out prime.
Yeah, we have interesting things.
Shouted Optimus first.
Yeah.
We have interesting things every semester. Yeah.
I still haven't heard like